Hello everybody, this is a video for section 5.3 over dividing polynomials. Make sure that you take notes and answer the survey questions at the end of the video. So for this first section, dividing a polynomial by a monomial. When dividing monomials, we subtract the exponents of the powers with the same base. This is something we talked about last week. If we get a negative exponent, we move it to the other side of the fraction bar and it makes it positive. However, when we divide a polynomial by a monomial, we use basically the same skills. Okay, so let's look at an example. Our first example we have 6n to the third plus 4n squared plus 2n, all divided by 2n to the third. So the easiest way that I can tell you to do this is to start by writing this into three separate problems. So this 2n to the third has to divide each one of these pieces on the top of my division problem here. Okay, so I get 6n to the third divided by 2n to the third plus, and this is because these are all positive, they're plus, 4n to the second divided by 2n to the third plus 2n over 2n to the third. Okay, so next I'm just going to do each one of these individual problems. So 6 divided by 2 is 3. Then n to the third divided by n to the third, subtract our exponents, and we get n to the 0. Okay, we'll come back and simplify these as once we do all three. Okay, 4 divided by 2 is 2. N squared divided by n to the third. 2 minus 3 is negative 1, so we get n to the minus 1. And then 2 divided by 2 is 1, so I'm just going to leave that off. And then n to the first divided by n to the third. 1 minus 3 is negative 2, so we get n to the negative 2. Last step is we need to fix our negative exponents and get rid of this n to the 0. Remember that n to the 0, anything raised to 0 is 1. So 3 times n to the 0 is just 3. And we get plus 2, and we bring, since it's a negative 1, we bring it down to the bottom, it becomes positive. So 2 over n plus 1 over n to the second. And this would be our final answer. And it's actually already in standard form since our exponents are in descending order. Okay, so let's look at next part. Dividing just polynomials. A similar process to long division can be used to divide a polynomial by another polynomial. Remember, we can only add and subtract like terms. Okay, so let's look at an example. So we have 3x squared minus 15x minus 72 all over x minus 8. Okay, so we're going to set this up like long division like you did in elementary school. So we'll have x minus 8, do our division symbol, and put underneath of it the big quadratic here. 3x squared minus 15x minus 72. Okay, so now we need to ask ourselves, how many times does x go into 3x squared? Okay, so in order to get x to 3x squared, I need to multiply it by 3, and I need another x to get the square, so I multiply it by 3x. Okay, so I'm going to put that above the 15x since they're like terms. Okay, so then I go through and I'm going to multiply my x minus 8 here by 3x. So 3x times x is 3x squared. Then 3x times negative 8 is negative 24x. Okay, draw a line underneath of that, and I'm going to subtract these two. Okay, so now I'm subtracting, and I'm actually just subtracting the entire equation here. So what I'm going to do is I'm going to change, instead of having a minus, I'm going to change all these to the opposite sign and then add straight down. So 3x squared plus negative 3x squared is 0, so I'm going to cross those out. And then negative 15x plus 24x is going to be 9x. And then since this doesn't have anything, we're going to bring it down. Next question I need to ask myself is I need to ask myself how many times, what do I need to multiply my x here to get to 9x? Well, to get from x to 9x, I need to multiply it by 9. So I'm going to put a plus 9 up here at the top. So I'm going to multiply straight through 9 times x minus 8. So I get 9x minus 72. Now, if you have any idea about long division, if you remember anything, you might see where this is going. So we're going to subtract. And like we did before, we're just going to change the sign of everything on the inside here. Change this to a plus. So 9x plus 9x, or negative 9x, sorry, is 0. Negative 72 plus 72 is 0, so we get a remainder of 0. So our final solution ultimately when we divide these two is 3x plus 9. Okay, now let's look at one more example where we have a remainder. Okay, so same process. We're going to start by setting up my division problem. So we get x plus 9, my division symbol here, 2x squared plus 17x minus 16. And remember, you can pause this video at any point in order to write down these examples and rewind if you need to. So we ask ourselves, what do I need to multiply x plus 9 to get to the 2x squared? Okay, so we have an x, so we're going to multiply by a 2 and another x to get the squared. Okay, so 2x times x plus 9, we get 2x squared plus 9 times 2 is 18. We add on the x. Okay, now we're going to subtract these two. Remember when we subtract, we change all the signs on the inside, make an addition symbol. So 2x squared plus negative 2x is 0. 17x plus negative 18 is going to be negative x. Okay, and we bring down our negative 16 from up there. Next, we need to ask ourselves, what do I need to multiply my x plus 9 to get this negative x? Well, I need to multiply by negative 1, so I'm going to put a negative 1 right here. So negative 1 times x plus 9, I get negative x minus 9. I'm going to subtract these two. When I subtract, it changes all the symbols on the inside. It makes this an addition problem. So negative x plus x is 0. Negative 16 plus 9 is going to be negative 7. And this is going to be our remainder. We have the negative 7 left over. Before in the previous problem we had 0. Now we have a number left over. So what we're going to do is our solution is going to look something like this. We're going to have 2x minus 1. And we're going to take this negative and we're going to put 7 over what our original dividend was, which is x plus 9. And that is our solution. Okay, here are the survey questions. Please answer these on your paper and come into class with any kind of questions. Have a good rest of your day.